So what I want to do is talk about positive work. From the website, we talk about work two different ways. We talk about work as being the process in which we transform one type of energy into another type of energy. Now, we haven't talked about energy itself, but understanding that if I took an object from high orbit, it has what we call gravitational potential energy. It has stored energy. As it falls towards the Earth, that stored energy gets transformed into kinetic energy, motion-based energy. So the process of transforming it from potential to kinetic is work. Okay? The process of changing it from one type of energy to another type of energy is called work. Another example of that is a car crash. You take a car, you slam it into another car. You've done work. It may not seem like it, but you have. You've taken your motion-based energy, the motion of the car itself, that's energy. When that car hits something else, be it another car or a wall, you've crushed the car. Now, there's deformation that goes involved. So some of the material is shifted into a different altitude, a different height, a different geometry, which stores energy. It also generates heat. It generates what we call thermal energy. Or the last type is it creates sound. So it creates sound energy. So you've done work. There's work being done. You've taken that car and you slammed it into the wall. Work is done on that car, transferring its kinetic energy into all these other different kinds of energy. Okay. Now, one would argue that it's a non-conserved system, and that most of this energy, well, almost all of the energy that's in the car is lost into the atmosphere, and you're no longer going to be able to use it. That doesn't matter for what we're talking about. What we're talking about now is that work is the ability to transform from one energy type to another energy type, or even potential to potential. It doesn't matter. Okay. Just transforming energy from one type to another. Okay? The other way in which we talk about work, which is probably more appropriate when talking about positive and negative work, is the attempt to change the motion of an object. When we talk about positive work, we're typically talking about taking an object and attempting to speed it up. Okay? Not velocity, speed. There's no direction that's associated with that. It's just an attempt to make that object go faster. Okay? Not in the positive X direction. Not in the positive Y direction. It just says, I can do work. I'm going to try to make you go faster. Okay? Now, to make an object go faster, what do you think you would do? Well, hopefully you'd push on it. You'd take an object. Okay? And you would apply a force. Okay? So what we say when we're talking about positive work is if I applied that force, and that force pushed that object a particular amount of displacement, then positive work is done. If the force and the displacement are in the same direction. Okay? If I push in this direction and the block slides in this direction, then I've done positive work. Now, it doesn't necessarily mean that the object has sped up. There may be other forces in the system that are doing negative work, and that's another slide. That's another situation. And the perfect example of this is you ever taken a couch and pushed it across the floor. Well, once you push the couch across the floor and you push the couch across the floor and you let go, what happens? Its motion's not changed. It's still zero. You pushed it and you let go and it's stationary. Okay? Because there's more type of work going on there than just you pushing it. But the attempt to speed up that object is this idea of positive work, where you're applying a force and the object moves a particular amount of distance, or more appropriately, displacement. Okay? It goes from this position to that position. It experiences displacement. That's what we call positive work. Okay? So force has to be in the same direction as displacement in order for there to be positive work. Now, you may be able to do this. you may apply a force up in this direction. So you've got your refrigerator, and you're pushing it this way. I don't know why, but you're pushing it this way, and the object moves that way. So your force vector is up in this direction, you're applying a force in this direction, but it moves that way. Okay, obviously you're not pushing that refrigerator up into the air. It moves a distance this way, a displacement this way, if you will. Okay? What we say in that case is that there is a portion of force in that direction. That this small component of the force, not the entire component, but only the force that's in the same direction as the displacement, does work. And if they're pointing in the same direction, it does positive work. We say that this component of the force does no work. It's wasted. It contributes nothing to my system. Now, why would we do that? There's other things going on here that you may not get. If I apply a force in that direction, I'm lifting that object off the ground, I'm reducing its normal force, and in turn, reducing the force of friction. So it may have a benefit. Okay? As a matter of fact, let's say you're towing something across the ground. You're towing, let's say, you're pulling a grate across the ground. You're more than likely pulling it at an angle. Okay? So only a portion of that is actually creating work, attempting to change the motion of the object. And remember that positive work is attempting to increase the speed of that object. Okay? Cool? So that's positive work.